Aloha, my name is Kevin Kimball and I'm an Associate Professor of Accounting at BYU Hawaii. The purpose of this video is to help you learn how to compute the future value of a retirement savings account based on key income figures as well as contribution and earnings rates as input by the user. You'll notice that in order to compute someone's retirement investment balance many years from now, we would need certain key input figures as noted off on the left hand side. Key concepts are: how long do you have to invest, when are you starting, what's your salary at the beginning, what kind of raises do you expect you're going to be getting, how much will you be contributing into your account, how much will your employer contribute for you, what rate of return do you expect you're going to get on your investments, and how much money are you starting with. Here I've provided a summary answer section. So in this example, if this person starts at 25 and plans on retiring at 65, starts with an annual salary of $50,000 with a certain annual raise percentage and certain contributions for himself and by his employer with a certain rate of return in this beginning investment, this individual will have earned and have in his investment account at 65 years old $1.5 million. So that's kind of the big idea, and all the detail down here below justifies that. Let me fix the panes so we can go down and see that. Here under View, if I choose Freeze Panes, what that'll do is it'll fix these rows from where my cursor was on up and fix these columns from where my cursor was to the left. And so I can actually go off to the left here and you can see that the year stays, and I can go down below and you can see all the titles stay. So if we went down to 65, you should be able to see that the ending balance of 1.5 million here matches 1.5 million there. We have a check figure. So that's the purpose of this video. Hopefully by working through this you'll be able to learn how to do this well and do it quickly. What I did is I just went and unfroze those panes. You know, it's under View, Freeze Panes. I can freeze it, and I can also unfreeze it, and that's the purpose of this video. So to get going on this video, we will have to choose Start, All Programs, go to the Microsoft Office, and choose Microsoft Office Excel. And that'll bring this up. You weren't able to see that. I had it on another screen, but hopefully you've already learned how to get into Excel, and we'll go from here. To start off, let's go ahead and title this Retirement Savings Calculator. This will be prepared by Kevin Kimball, prepared on, and I'll just type equals today. Purpose: to compute the future value of a retirement savings account based on key income figures as well as contribution and earnings rates as input by the user. Now we'll have a data section starting in row 6 here. We'll leave a lot of the formatting to the end. Here in cell B8, type today's date. We'll have a current age, retirement age, annual salary, anticipated annual salary increase, annual employee contribution percentage, annual employer contribution percentage, expected return rate, and the original investment balance. Now I'm going to show you a quick way to name these cells, and I'm going to put them right next to I'm going to put them in cell C8, and then what I'll do is I'll cut them and paste them over to E in a moment. But I'm going to use the define name feature. If you look up here under formulas, define name, and I choose the drop down and choose define name, you'll notice that it guesses what you'd like that name to be. As you can see, it got rid of the apostrophe and put an underscore, and it got rid of the space and put an underscore. In other words, when you're defining names, you cannot have spaces. And you can see this has an absolute reference to cell C8. And I hit OK. So that's one way to name this cell directly adjacent to the title. If I went over here, let's say in E9, and tried to do define name, it wouldn't know what you think the name should be because there's no title directly next to it. So I'm going to name all these just right next to it, and then I'll move them later. So I define name, and I like that name. And I hit enter. Hit define name. I like the suggested name. Hit enter. So I'm just moving down one, and I'm accepting. The other way you could do it, especially since these are going to be long names, I would recommend maybe you just go up here into the name box and then you type anticipated annual salary increase. Otherwise that would have really been quite a long name, although it is still long. It's at least shorter. This one, let's get up in the name box, type EE, standing for employee contribution percent. And then we'll go down to the next one, ER contribution percent. Now this next one, maybe I'll use define name again, and I like the name that it comes up with, and I'll hit enter. Next one, maybe I want to shorten this, and so I'll use the name box, Orig Invest Balance. So what I did is I named all these ranges, and what I can do is I can now put my cursor in C8, hold the shift button down, and highlight all those cells that I just named. And this time I'm going to use the move button, not the copy. And the move button is Ctrl X. Ctrl X. Or if you're up in home, you could cut. Ctrl X and cut are the same thing. When you use Ctrl X, these references, cell references, remain the same. So Ctrl X, move over to column E because I want a little space between these titles and the names. And that just saved me a little bit of time. And as you can see, test it out. Go into cell E8, you should see that the range names came with them. So all those seem to be good. So main purpose that we just completed right now is naming all of these cells. Let's start putting in some numbers. For example, today's date, let's just put in today. Current age 25, retirement age 65, annual salary 50,000, 3, and I'm going to put in percent, which is one way to do it, or you could put in 0.04, but then you'd have to go back and you'd have to format that as a percent. Either way works. I tend to like using just the putting in the 8, for example, and then typing percent because I keep my hands on the keyboard. The original investment, let's say it's $1,000. While we're here, let's format these percentages by holding the Control button down and dragging over the percentages, and let's make those show 2 decimal places. Our salary and our original investment, if you notice here, as I put in 1,000, it thought I was still doing percentages, so it thought that was a 1,000%. That's really not, so let's change this to be currency. And you see it thought that that was $10. I need to change that back to $1,000. And another thing while we're here, why don't I just show this? I've got this formatted how I want, and I can go up to Format Painter. So I click on the format that I like, click Format Painter, and then choose what else I want formatted the same way, which in this case was annual salary. And now that that's too wide for the column, I have to drag the column width over a little bit so that you can see the full number now that's been formatted. Next thing we're going to do is we're going to create a lookup table. One thing you'll know is as you hire on with a new employer, at least in the United States, they have something called a 401k plan where you can put money into a savings account pre or post-tax, depending on the type of 401k. And then your employer will also put in some money for you. So I'm going to create a table. This is a table that you might see at your new employer that shows you how they are going to match your contribution. So let's say you put in 1%, maybe your employer will put in 1%. What that means, 1% of your salary. So for example, if you put in 1% of $50,000, that's $500, the employer will also put in 1% of $50,000, $500. So in total, what will be contributed to your savings account would then be $1,000 per year. Next one, 2%, 3%, 4%, and 5%. Let's say for the 2 and 3%, I'll go Control C, so I shift and held down and drag to the next row. Those are all the same, but maybe at 4%, they're only going to put in 3.5% of your salary. So in other words, they're only matching 50 cents on the dollar above 3%. And then at 5%, it'll be 4%, so same idea. We're going to format all these to be 2 decimals so that we can recognize that. And I'd like to highlight all of these data variables. So I'm going to hold the Control button down and I'm going to drag over all these variables which the user needs to input. And I'll go up to the home font, and I want to change this to be maybe a green, and I'll put a box around these, maybe a dark border box around these, just to designate what the user needs to input. So I think those are pretty good, but as you can tell here, I did not manually, I didn't do this. I didn't say, oh, it's 4%, okay, well, and I personally look in the table and say, oh, okay, that's 3.5%, and then hard code that number as 3.5%. Why would I not want to do that? Well, because it takes my time, and I don't want to take my time doing things that I can get the computer to do for me. So what we're going to do is we're going to use what's a new function, which is called a Vlookup. And what the Vlookup does is it will look up 4% in this table under the employee column, find where 4% is, and then return the corresponding employer value. Now if this were 4.2%, it says, is 4.2% greater than 1, greater than 2, greater than 3, greater than 4? Yes, it is. Is it greater than 5? No, it's not. So it goes back to the last one and returns the approximate match. It's kind of like your grades. You know, if you had 91% and the next grade higher is 93%, you would get the A minus at 91% rather than the next highest. But we will do a lookup here to get that number to type in for us. Before we do that, let's do what's called a completeness test. One thing that happens sometimes is when we're requiring users to input data, sometimes they leave data out and then it blows up the whole spreadsheet because they're trying to find data that doesn't exist, and you get these error messages down below. So we're going to create something called a data completeness test, and I'm going to ask the question, is the data, that's D-A-T-A, is the data actually complete? In order to know whether the data is complete, manually you would have to look. Is the value in there? Is the value in there? And if all these values are in these areas, then you'd say, yes, it is. And I'm not going to worry about the completeness of this table. I'll just assume that that is complete. And the way we're going to do that is we're going to nest a function called OR inside of an if statement. And if you kind of stick with me, you'll see how it works. I'll build it up piece by piece, but I think you'll find this to be a useful. So in my data completeness, this is what I'm going to do. I'm going to say equals if. Okay, so I'm doing an if test. So if this logical test turns out to be true, then it will do the first thing. it will bring back whatever's in this after the comma. If it's false, it'll bring back whatever's in the second comma. So here are going to be our tests. We're going to do an OR, okay? And I'm going to say, if any one of these are blank, if this is blank or this is blank, if any one of these are blank, then I want to say, hey, data is not complete. In other words, data complete? No, it's not true. So I'm going to do these. Is today's date equal to blank? Or is current age equal to blank? Or is retirement age equal to blank? Or is salary equal to blank? Or anticipated salary equal to blank? And you can see I'm just going on and on. I'm just clicking each one of these. Are any of these equal to blank? Are any of these empty? Expected return rate equal to blank. You notice I don't bother with the annual employer because this will be a formula looking up over here, so I don't have to worry about that. Expected return rate equal to blank, or is original investment equal to blank? Okay. So right now, none of those are equal to blank, and so this OR statement will turn out to be false. This OR statement will give the answer no. None of those are equal to blank. So if you look at the if statement, it will do the second piece rather than the first piece. Now, if any of these were blank, meaning the data is incomplete, I want to say true. No, sorry. If the data is complete, I want to data is incomplete. So in other words, if any of these have a blank in them, this OR statement will say that it's true, that there are missing data. But my question, data complete, is the data complete? No, the data is not complete. It's kind of a double negative, but hopefully you get the idea. If it turns out to be true that the data is incomplete, then I want to tell people that the data is not complete. So the data complete question would be false, and then opposite to that would be true. So if we get through the whole OR and every single data item is in there, then the answer to the OR is not true, and therefore the answer to the question, is the data complete, will be true. I know that sounds weird, but that's really what it's doing. And we just finish it up, and we've got our OR beginning parentheses and ending parentheses. We've got our if beginning parentheses and ending parentheses, and we should be good. So let's just test and see if that's right. So is the data, if I change this column a little bit, is the data complete? So that's what this question is. Maybe I should even change that. Is data complete? And I could, why don't I even change this, just so my question is a little bit better. I'm going to get in and I'm going to edit this by clicking up here. And instead of saying false or true, why don't I just say, is data complete? I can say no, it's not. Or is data complete? Yes, it is. And I'm going to put a single apostrophe there. I guess it won't let me do that. I guess I will have to go back to the false and true. So let's test and see if it's working the way I want it. So if you look here, is the data complete? Yes, it is, so it is true. But if I were to delete current age, is data complete? No, it's not, so it's false. That's all I'm trying to do. And so best thing to do is just look at this formula, make sure you're getting the idea. I've got a test here, which is the OR, and this test gives a true or false answer, and if this test OR is true, it will return the word false for whether it's complete or not, and if it's false, it will return true. And I know that's weird, but I guess I could change the wording here. Is data incomplete? And then maybe that would line up better for how you might be thinking. But hopefully you get the idea of what we've just accomplished here. Now let's do the lookup. We want to look up the employer contribution percentage. So the way that's going to work is I'm going to say if And I'm going to test whether the data is complete. So we're testing if 816, if that, so this answer is already true, right? So that the logical test was already performed in here. So we're just saying if 816. In fact, why don't we even step back one? We'll name this cell so we can always refer to it as a contribution test. Sorry, I meant a completeness test. So why don't we give this a name? As you know, we can go to formulas here, and since the title is right next to it, we could go to define name, but I'm not sure that's going to give me a name that I like. Is data complete? I don't know that I really want to use that. I'll just call it completeness test. Or I could say, is data complete? Could do it like that. And so now I have a name there. And now what I'm going to do is I'm going to test, is data complete? If it is, then I'll go ahead and do the lookup of these values. So, equals if, and then I click on this cell, is data complete? And that's the full test. If it is, then I'm going to do a Vlookup. And I'm going to look up this employee contribution percentage. And I'm going to look it up in this table. And I need to go down to row 14. See, here's 13, which is 4%, and then 14 would be 5%. So I'm just testing. I'm finding this percentage in this table, and then I'm going to return the second column from that table, and then I will end it. There is another option there, whether it's an approximate match or an exact match. I won't take much time on that now. Just remember, an approximate match would allow you to put in numbers like 2.5 and it would return 2%, or 3.2 and it would return 3%. So it can handle numbers in between. If you choose exact match, it has to be exactly in the table. So if you put in 2.2, it would return an error if you're using an exact match. So I'm going to use an approximate match. That is the default, so whether you put that in or not, it will be an approximate match. If you don't want approximate match, then you have to use exact match. Another point is this lookup table, if you're using approximate match, it has to be in ascending order from lowest number to highest number. So let's finish that up, and I would then put in comma, double quote, and so what this says is, first I'm testing, is data complete? If it is, then do the lookup, find the correct corresponding employer contribution percentage. If it's not, then just return a blank. And I can hit enter. Good, so let's see if it's working. Let's change this to 4%. So if it were 4%, it would test is 4% bigger than, bigger than, bigger than. It gets down to here. Is it bigger than or equal to, I guess? Yes, it is. Bigger than or equal to 4%. Is it bigger than or equal to 5%? No, it's not. So an approximate match would go back to the last number and return its corresponding value. Now, one last thing. As you can see here in cell E14, I have this formula, and it's looking up in a table which is G10 to H14. One nice thing is you can go and name this table even after we've created the formula, and we can call it contribution table. So it's now named, but if you look at my formula here, the name didn't change. So a nice thing that we can do to apply any new range names is we can go up to define name under formulas, define name, and we can choose apply names. And contribution table is selected, but just in case maybe all these haven't been applied in their respective formulas, I'm going to click all of them and hit OK. Now if you look at my formula, F2, you can see the word contribution table, that name is now in place of the cell references of G10 to H14. So that's kind of nice. So if maybe you go and create formulas and then later on put in range names, you can always come back later and use the define name, apply names function to bring in the correct names into your formulas and make them easier to read. That finishes up my data section. I'm going to put in some space here for the summary answer section, but we won't use it right now because I want to do the detailed answer section next. Detailed answer section. And in the detailed answer section, I'm going to have some key column headers. We have the year, and this will be like years 0 through however many years we might want to run it. Age would be the beginning age that this person is at the start of their investment period and go until they retire, or even longer if they choose to keep the money in there. Salary, beginning balance, the year-to-date, YTD stands for year-to-date earnings, the year-to-date contributions, the ending balance, cumulative earnings, cumulative contributions, the ending in balance. You can see I have ending balance twice. One will be the ending balance using this math here, and the other will be the ending balance using this math here. And then we'll have a check figure in the far side. We'll start with computing the year. With the year, you'll notice that all these formulas that I'm going to do next, I'm always going to go back and see, do we actually have complete data? Because if we don't have complete data, then I'd get an error message down here because it's trying to find data to be used in the formulas that doesn't exist. So I'm always going to start off these formulas with an if statement, testing to see whether the data is complete. If it is complete, then it will do the formula. If not, then it'll put in a blank. So, for example, here for the year, I can say if data is complete, then put in a 0, because that'll be year 0. Otherwise, put in a blank. So in this case, since the data is complete, it'll put in 0. Now, if I were to delete age, for example, you can see that the year disappears. In other words, the double quote blank is now entered into that cell. So if I put back 25 under current age, then it comes back. Now the next year, I don't want the same formula. The next year, I'm going to test that again. I'm going to say if data is complete, then take the number of the last year plus 1. And so that will help me to increment my years. I didn't want to just do a sequence 0, 1, 2, 3 and then use the cell fill handle and drag it down. I want to use a formula that's going to make sure that I do have valid data. And so now that I've put those two in there, I actually only want to copy this one. I don't want to copy this formula above because that will always put in 0 if the data is complete. I actually want to put in the next year. And so I've got a good formula there. I'm going to drag it. I think it goes down to about, I think it's around 88 or so. Let's just see what number I get. Yeah. So if I drag that down to row 88, I get 60 years. So if I started at 25 and added 60 years, you know, you'd be up into your 80s. So I'm going to go end up. And so I've got all my dates there. This row 0, I don't need really any of these other values here in row 0. Maybe just the ending balance. So my ending balance would be, I'm going to test first if data is complete. And if it is complete, then I want the ending balance for year 0 to be the original investment. Otherwise, put in a blank. And that same formula, what I can do to copy that same formula, I can go up here into Edit and copy and paste it. Or I can just, since these are absolute references, these are absolute references up here, I can go like this and copy and then move over to ending balance and hit enter and paste, and as you can see, hitting the F2 button, it's the same ending balance. Okay. Now my check figure, I'll do a test if completeness test, then take the ending balance computed using this information minus the ending balance computed using this information. Right now, obviously it's going to be the same number because the formula is the same, but you'll see that I change it on the next row. And then I have to do a double quote if it's not complete data. Okay. Now we're under row 1, year 1. We've got to put in the individual's. Now to put in the individual's age, rather than going back each time and just testing whether data is complete, I can simply test to see whether there is a value in year, because back here in year I already tested if data is complete. If it's not, then it puts in a blank, and so I can actually just test this column. I can just test if B29 is blank, then blank. Otherwise, then I can do the calculation for age, which would be the current age plus the number of years it's been since we started this investment. Okay, so that would give me 25, because current age is 25 plus the number of years that have passed, 0. Now if I copy that down one, you can see it works, because now it's taking the current age, which is 25 again, plus the number of years it's been since the beginning, which is 1, and we get 26. And if I copy that all the way down, it works all the way down. So I go end down, and you can see it goes up to 84 years. We could extend that if we wanted to, but we'll just leave it how it is for the moment. Next one, let's go on to the salary. In year 1, the salary is going to be, let's do our test here again. Okay, so if B29 equals blank, then blank. I'm going to do that every time. I won't take time to explain that each time I do it. I'm going to use that same beginning for all these other formulas, so just kind of be ready for that. I might go quickly through that beginning portion of the if-then statement. But if it's not blank, then what I'm going to do is I'm going to put in the salary for this individual, and I have to go up to find that. Okay, so in year 1, their salary will be whatever their beginning salary is. Now for year 2, I'll copy this down, Ctrl C and then enter. But as you can see, that formula is not very good because it doesn't include their annual raise. And so we're going to modify this a little bit to bring in their annual raise. The way we would modify that is we won't just take annual salary as is. What we're going to have to do is we're going to have to take their annual salary from the last year, and we have to multiply it by 1, which gives me the annual salary again, right? Taking prior year salary times 1 would give me the prior year salary, plus, and we're going to pick up the annual salary increase. So effectively what we're doing is we're taking last year's salary and multiplying by 1.03, which will give us the $50,000 plus 3%. And then I have to end it with another parentheses. And you can see when they're 26, they'll be making $51,500. So when you take your first job, you might want to be aware of what kind of salary increases you can expect. Now that's ready. And I'm doing these one by one, but you could just wait and do all these formulas at the end and then copy them all down. But I'll just do them one by one because it doesn't take much time. Let's go on to beginning balance now. The beginning balance formula is pretty straightforward in that all we're saying is the beginning balance for the current year is the ending balance for the prior year. So we'll put in our completeness test first, make sure we do have values, and if that's blank, then blank. Otherwise, just pick up last year's ending balance, and that would be your formula for beginning balance. So every year, whatever the ending balance is for one year will be the beginning balance for the next year. Just like in accounting, the ending balance sheet for one year is the beginning balance for the next year, beginning balance sheet for the next year. So I can copy that down. as you can see, there are zeros here because we haven't computed the ending balance in any of these other columns. So, but that'll take care of itself as we move along. This next column is the year-to-date earnings. Let me widen that so you can actually see the word. Year-to-date earnings, the way you widen that, you just put your cursor in between the two columns and drag, or you can just double-click, and that will automatically auto-fit that column. Under year-to-date earnings, once again, we will test, as you know. And now if it's not blank, we want to take year-to-date earnings would be the beginning balance times the expected return rate. Now that formula, each time, if we were to copy this down, this relative reference is perfect for E29, because when it copies down, then it would be E30, which would take the beginning balance times the expected rate for this row, and next row as it copies down. So it's good to keep this E29 as a purely relative reference, so that purely relative reference will change as it gets copied down to the different rows. So I can copy that down. And once again, these will show up zeros until we actually get these ending balances to come in for the beginning balance. So we're still right on track. Now the year-to-date contributions, this is actually going to be a sum of both the employer and employee contributions. We could have added another column that had employer contributions year-to-date and employee contributions year-to-date. I'm choosing to just put both of them together. That's up to you if you want to have two columns for the contributions to show employee and employer separately. But I'm going to put them together in here. So I'm going to start off by testing our whether we have complete data or not. And now I'm going to take my D29, which is my salary, and I'm going to multiply it by the contribution percentages. So the contribution percentage for the employee plus contribution percentage for the employer. So what this does is it takes your salary and multiplies it by, in this case, 7.5%. That's how much you would have contributed that year. And by looking at this formula, I think it's good that these are fixed. I will always refer to employee percentage and employer percentage. But the D29 needs to change to be D30, D31 as I copy this down. So keeping this a purely relative is exactly how I want it, which would allow me to then copy that down. And you see that works because there is a value in the salary. Good. The next one is our ending balance. The ending balance for any subsequent years after the initial year 0 would be the beginning plus your earnings for the year plus your contributions for the year. So we'll put in that formula. Once again, we're going to test for blank and blank. But now, this is simply a sum. You just sum your beginning through your earnings and your contributions, and that would be your formula. So that would give you the cumulative ending balance as of this point in time, which is correct. We started with 1,000, then we threw in 80, we threw in 3,750. If you add that up, that's 4,830 in total. So this is current year additions were 3,830, and you add 1,000, 4,830. And I think that formula is good as is, so we can copy that down, and you can see all these other numbers now up here. Moving on to our cumulative earnings. For some of you, the word cumulative may be a new word. I'll type it all out. Cumulative. Cumulative means it's added numbers up over a period of time. It's accumulating the numbers. So these are the cumulative earnings. So the cumulative earnings would have to be, the cumulative earnings at any given year would have to be the cumulative earnings from the prior year plus any new earnings for the current year. So that's what this formula is going to be, is we're going to compute the cumulative earnings. As soon as we get there, we will show that math. Okay, so the cumulative earnings would have to be cumulative earnings for the last year plus any year-to-date earnings for the current year. and that's your cumulative earnings. So right now, since there were no earnings last year, but we do have earnings in the current year, we have 80. But if we copy this down one, you can see we had 80 from the last year and add 386 for the current year, 466, and now that formula can be copied down. Cumulative contributions. I'm going to widen these columns so you can see these words a little more fully. Double click, and I can come back and clean that up a little bit if necessary. But cumulative contributions is pretty much the same idea. I'm going to first test the data completeness. But now my cumulative contributions would have to be my cumulative contributions from the prior year plus the contributions for the current year. And with that, I can hit enter, and I have 3,750 cumulative earnings. Why? Because I had nothing last year plus current year. And bring it down one just to test it out. I had 3,750 from the prior year plus another 3,862. That math looks like it's correct, and so I can copy it down. Once again, I could have done all these formulas at once and then highlighted the whole row and copied it, but I'm just doing it one by one just because. Moving on to our ending balance. Now the ending balance here is going to be a little trickier because these cumulative columns already pick up all earnings to date. So really all we'd have to do to get the ending balance would be take the ending balance from the prior year and then add all contributions from the beginning of time. So this math is a little different than what's going on over here, so be careful that you understand the difference. So let's do the math here. It's going to be first to test the whether it's blank or not, and then put in blank if its data is incomplete. And I'm going to now take the beginning balance, but I want to make that an absolute reference because I always need to take this very beginning balance, no matter where it gets copied down below. I always need to start with 1,000, and then I'll just be adding the current cumulative earnings and contributions to date. So I pick up the cumulative earnings to date, cumulative contributions to date, and now I can copy that down one just so you can see it. So what I had is I had 1,000 and I added all the contributions to date, 4830. Then I had 1,000 and the cumulative contributions and earnings to date are these two columns which already include these numbers in there. So hopefully you understand the math that's going on. And just to check, you can see that the ending balance as computed under this method is the same as over here, and I can double click that down. And those, now we're going to test whether they match or not. Now in the check figure over here, we're going to test if our cumulative approach to computing ending balance agrees with the current year approach to computing the ending balance. And we've already done this check figure here. We ran it off of is data complete. If we want to change that, go back and hit the edit button here. I can get rid of the is data complete, and I could just do a test off of the year 0. Either way, I'm okay either way. I think I'll leave it as is, and I'll just double click. Now if you see these, it looks like there's an error here. In other words, the check figure doesn't reconcile, but that's actually a very, very small number. If I highlight that whole column, which it already is, and go up to home and set maybe a comma style, you'll see that those are very, very minor rounding differences. While we're here, let's highlight the whole range. What I did is I just dragged and dropped. I selected and I held the shift button. In fact, I actually want to start in salary. I want to start in salary because I'm going to format all these. So I clicked in salary, hit the shift button, then clicked in L28, so it highlighted all that, and then I can go end, down, do it one more time, end, down, and I've selected my whole range, and I can just put maybe a comma style. And now all that's formatted for me. I might choose to highlight these two columns, end, down, and maybe do a center. And it's a good idea to go all the way down to the bottom and see if you've got this type of problem with the formatting. One way we can just take care of this all at once is maybe highlight all of these columns. I'm clicking at the very top on D and then holding my left mouse button down. And here I can just right click now on D and set a column width to maybe 16 and end down. It seems like that's going to be wide enough end up, at least for what I would expect the values to be. So I think we've got our detailed answer section working. Now we can go up into our summary answer section, which effectively will pick up these key figures down below based on the year of retirement. The titles I'm going to use up here, we'll start up here in row. I'm going to move my answer section, summary answer up one more row, I think. I'm going to Control X, move that up. And then on row 20, I'll put beginning investment, do employee, employer. I can do total. This will be total earnings, and then balance at retirement. So these are the key figures I want. Up here, I'd like people to know that both these columns, all three of these columns, are contributions. So sometimes this is what I do. I'll put in a single apostrophe and I'll put a backslash, because if I just put the apostrophe in by itself, it will think I'm doing math, division. So I have to put a single apostrophe to say, hey, what's following is text. And I'll put in some dashes and then type in the word contributions and put in some more dashes and get to another slash. So that tells people that these are all contributions. Down here under beginning investment, we're going to test if the data is complete. So we're going to test is data complete. If it is, I want to bring in the original investment balance. Otherwise, just put in a blank. So in other words, that's my beginning investment. Now I'm going to just pick up total contributions, then I'll back into the employee and the employer portions of that. So for my total, I can type in equals if, and I want to test if it's complete. If it is complete, I'm going to do a Vlookup. And this is going to be a little unique. Vlookup. And I want to look up the age of this individual. I want to look up their age. And I want to look it up in this range. All of our data completeness, all of our detailed data, and I'm going to shift in down. Okay, so what I'm doing is I'm going to look up in all of my detail, and I'm going to try to find that person's age. And once I do find it, I put a comma. I'm going to go up here. What column do I want to have returned? Well, I'm looking up total contributions, so I actually want a cumulative contribution. So if I count the columns, age column in this range is 1. So 1, 2, 3, 4, 5, 6, 7, 8. So cumulative contributions to date are in the 8th column of this range, and so I put the number 8. Then I can end my parentheses, and then if the data is incomplete, then it's blank. So hopefully you've seen what I've done. I've simply selected this range, and I'm using it as the lookup table. I'll look up retirement age in this table and return the 8th column for whatever age that person is. So let's test that. This person's 65. Let's go down to the age 65, and it should be, I'll change this to be a comma, 294,000. So when they're 65, they should have cumulative contributions. And before I go down too far, I'm going to go up and I'm going to freeze these panes so I can actually see the titles. So I'll put my cursor in cell C28, choose View, and freeze panes, both row and column. So now I'm going to go down to 65, and that helps me read these as I go down low. And cumulative contributions, 294,987. So let's see if that worked. Control Home. I'll have to unfreeze those panes. 294,987, 294,987. So what it did is it found their year 65 and returned the corresponding cumulative contributions. Now, to determine how much of those contributions are employee and employer, all we have to do is go back to these percentages which we have before. As you can see, total contributions, if I add these two together, let's add these two together, sorry, that and that, is 7.5%. Okay, so in other words, 7.5% of the person's salary in any given year is in this contribution here. So what percentage of the 7.5% is employee? Well, it's 4 divided by 7.5%, so a little over 50%. How much is employer? It's a little less than 50% because it's 3.5 divided by 7.5%. So that's what I'm going to do to come up with employer. I'll take 3.5 divided by 7.5% times this total contributions, and to come up with employee, I'll take 4 divided by 7.5% times the total contributions. So I just wanted you to catch the vision here before I get into that math. So we'll go first to employee. So under employee, we will test whether the data is complete by typing in the completeness test. Is the data complete? If it is, then we want to take our total contributions and multiply it by this ratio of the employee contribution percentage divided by the sum of employee plus employer. So that's the 7.5%. So I'm taking the 4% divided by 7.5%, and then finishing up with another parentheses to make sure my beginning and ending parentheses here match, beginning and ending parentheses here match, and then I'm still in the if statement, so I have to finish up with the double quotes if it's not complete, and that's what your formula would be. So I'll hit enter. So what that says is of this 294, 157 is employee contributions. Now we'll go over to employer. I'm sure some of you are probably already saying, well, Brother Kimball, you could just take this total and deduct the employee, and that would be the employer, and you're absolutely right. But let's just prove it out mathematically as well. We're going to do our completeness test, and then we will take our total contributions, which is here in E22. We have to multiply it by the employer contribution divided by the employee plus employer contribution percentage. Finish with the double parentheses and then double quote. So hopefully you can see the idea there. We've got the total contributions multiplied by this ratio that made up the employer portion, and we've got it. Now if we just want to check that to make sure that that's correct, we can have a little check figure down below. Maybe we'll just call this check figure. This is self-auditing. It's a good idea to do check figures, make sure you're catching possible mistakes, and so we're going to put a little self-auditing check figure here. In this check figure, once again, we will do our completeness test. We'll make sure that that is complete. And then if this is working correctly, then we should be able to take E22 minus the sum of these two, employee and employer, and that should come up to be 0 if it's working correctly. And then if it's not complete, then it's a blank. We'll format that so it looks a little bit nicer, because that's just a rounding difference. And it looks like we reconcile. Now we can go on to total earnings. In total earnings, we're going to use the same idea as we did for contributions. In contributions, we looked up the retirement age in our table down below, and we returned the 8th column. Well, this time we want the earnings, which is the 7th column, because salary is, I think age was the 1, 2, 3, 4, 5, 6, 7. So the cumulative earnings in I is the 7th column. So let's do that formula. We're going to do our completeness test, and we'll do our Vlookup again. And as you recall, you could have named this whole range. I didn't do that yet. We can come back and name it later. but I'm going to highlight that whole thing all the way down to the bottom. And I got one step ahead of myself. Let me delete that. I forgot to input the what we're looking up. We've got to first, in our Vlookup, we've got to first say, well, what are we looking up? We're going to look up their age. And where are we going to find their age? We're going to find it in this table. So now I'm going to go down and highlight this. Hold my shift button down, N down, but the big idea is make sure you select that whole range, C29 to L88, assuming you did it exactly as I did. And I'm going to return the 7th column value, which is the earnings column, and then I'll put my comma, double quote. So if you look at that formula, that should get you to where you need to be to return the total earnings. And then balance at retirement is a similar idea. Now, before I do the next one, I might choose to go ahead and highlight this again, end over, end down, and why don't I name that detailed answer by age. So I've got it named, and as I mentioned before, if we go up to our formulas, define name and apply names, I want to apply that detailed answer by name. And now if I get back into my employer into my places where I looked it up, under my total contributions, you see that instead of having the range references here, it now says detailed answer by age. And you see under total earnings, it now says detailed answer by age. So I brought in that name even though I didn't have it created at the beginning. Okay, now under balance at retirement. Balance at retirement, we're going to do our test again. And we're going to say balance at retirement would have to be equal to our B22, which is our beginning balance, plus cumulative contributions, plus cumulative earnings, and if it were blank, then blank if data were incomplete. So we get 1.5 million, and we can do a check figure down below. In the check figure, we'll use that idea of the lookup. So once again, if Completeness Test, and we're going to do a Vlookup, because we want to look up that age and the ending balance for this person. Vlookup retirement age. I can just start typing if you haven't noticed that already. Instead of clicking up here, I can just start typing retirement, and you see that down below the named range appears, and I can now start typing detailed answer by age. If you notice that, double click on that, and I want to return the 9th column value. So the 9th column value, 1, 2, 3, 4, 5, 6, 7, 8, 9, ending balance. So I'm going to look up their age and return the corresponding ending balance. And I want to deduct G22, which is this other computation of ending balance. So this is one computation of ending balance, and I want to deduct the other computation. So if they reconcile properly, this should come up to be 0, comma, double quote, and I'm done. I believe we've got all the key figures in here now, so from here forward we're simply going to be doing some formatting. I'll try to go slowly as we go through this. On Retirement Savings Calculator, I'm going to Ctrl B, prepared by, Ctrl B, which is bold, prepared on, Ctrl B. And under Purpose, I might choose to get in the Edit in the formula bar here and just highlight Purpose and Ctrl B, Ctrl U, and hit Enter. I think that's good for that section. Under Data section, I'll go as wide as my table is wide, and I want to Control B the data section title, and under the Home ribbon, I'm going to change the color to be a color that matches these variable colors, and maybe put a bold around that. Looking in here, maybe I'll highlight all of these. Maybe I can go Control and click and hold Control and click, drag and drop with my left mouse, and maybe I want to center everything. That's personal preference, that's up to you. Under contributions here, I'm going to center these, and for contribution percentage, I'm going to highlight that and merge and center. What that means is it took these two cells and made them one, and it just looks a little bit nicer. Data complete, I think we're good there. Summary answer section, why don't we turn this a blue, so this will be a light blue. Put a bold around it, bold border around it. Do a light blue, and Control B, the name. We'll do the same thing here. We'll use the same coloring, bold and blue, and hit a Control B on all those, and maybe I will center all of them. Now, as you can see under beginning investment, this is a little bit too narrow, so we might need to make that a little bit bigger. What happened here with contributions, since I hit center and it was in cell C20, what I can do is I can hold the shift button down and then click on cell E20, and I can merge and center that, and that looks a little bit nicer. I'm going to highlight all of these values, and maybe I'll make them currency. Okay, I think that looks good. Moving down to the detailed answer section, I'm going to highlight this and make it maybe even a darker blue, maybe something like that. But I'm going to change the font to be a white this time, and why don't I bold it? Okay. Now here, one thing you can do to make big data tables easier to read, like if I'm way over here and I see 13,000, it might be hard to recognize that I'm on row 3. So what you can do is you can highlight this whole table. So hold your, in fact, here's a hotkey, Alt-A, sorry, Control-A I think is what it is. Let me try it one more time. Oh yeah, there it went. Let me get out of that. Hit Escape, Control Home. I'll just do that one more time. What I'm doing is I'm going to hit Control-A, and it will select this whole data table. Control-A. And up here, under the Home button, you should find under this Home button an option that's called Format as Table. This is kind of a nice option because what it will do is take all this data and it will change the coloring from one row to the next to make it a little easier to read. So I'm going to click on that, and you can choose any one of these that you like. I'll choose this medium and 1 over. I don't know if it'll give me the name of that type. This is Table Style Medium 2, but you can choose any one you want. It's a personal preference. But what it will do is it will change the coloring of the rows, and it will also filter the whole table. It's going to ask, is this the right range? Yes, it is. And it's going to ask, does my table have headers? Headers mean, does it have a column title? So you can see here, I do have column titles, so I'm going to leave that check. If I don't, then I would want to remove that and hit OK. So if you notice, very quickly, it just filtered the whole thing, and it changed this coloring. So for example, if I wanted to filter to prove out my numbers here, if you notice here I've got my, these are my numbers at age 65, I can filter this by removing the select all and dragging down and saying I want to see at age 65, and there you go, and we can look up just above to see if these ending balances match, for example, the cumulative earnings match, for example, cumulative contributions. So it seems like that matches, and that's kind of a nice thing, and you can filter that, and I'm going to bring it all back. One interesting thing, since I had two columns that were named ending balance, it then named it changed the name actually. This is end balance and this is end balance 2. So just be aware that it just does that automatically for you. I've tried to get rid of that end balance 2, but it won't go away because it is a filter, and each filter column needs to have its own unique name. One other thing we might want to do is just down here in the bottom right is just zoom it to be maybe about 93% so you can see everything at one time. I'm going to have to get my employee a little bit wider here. You could play around with column widths and all that stuff, but I think this is looking pretty good. I didn't put a bold around this detailed answer section, so why don't I do that? So what I'm doing now is I'm doing one last check. A common mistake that students make is they forget to run spell check, and I tend to get in a hurry and not do that. So I'm going to click on review and run the spell check. This is an abbreviation, so I'm going to ignore that. Next. Oh, okay, so it doesn't look like I have any spelling errors in here. It must recognize some of the abbreviations, so it looks like I'm good in that way. I think my figures all prove out. Let's test our blanks. So what I'm doing is I'm proving out my work. I'm going to delete, why don't I delete the anticipated salary increase? And you can see all this data disappears, and so I don't have error messages down below. So that's nice that I did that. I'm going to hit Ctrl Z to undo that, and I think we're good. So hopefully you were able to accomplish the objective of this case. I hope this tutorial helped you understand what you're expected to do and that you will be able to recreate this on your own. Now, I don't know if any of you noticed this, but I worked through that whole case without saving once. That would be a big mistake. As you can imagine, working that much and then not saving. You can see up here at the top it says book 1, so that means I have never saved this. And if something were to happen to my computer, I could have lost all that work. So contrary to what I just showed you, you do need to save regularly. So as you know, Alt-F-A is save as. Now, if you just want to do a normal save, you can just do I think it's Alt-S. Sorry. I do want to save changes. Let me go ahead and save that. So anyway, big idea is please save your work. Although I forgot to do that at the beginning of this. I'm so excited about creating this video. I would strongly recommend that you do save. So I'm going to save this as ACC 232B retirement calculator tutorial, and I want to save that as an Excel workbook. So this is the finalized one. That's the one that I showed at the beginning of the video, and then I just redid the whole thing, and I'm going to save that. So hopefully you caught that. I will clip this on to the very end of the whole thing. So